Hello. So part F is the last part in question 1. After this, we'll go on to question 2. So this part is asking us to find the simultaneous equations of this question. So most of the rules that we are going to be applying here are the rules that we have already been applying in the other questions. So we'll not state them. You can refer to the previous videos so that you see some of the logarithmic rules that we talked about. So we start with our question 1. Question 1, which says, so we're finding the simultaneous equation of 2 power y equal to 4 power x. So we can name this as our equation 1. And then also for 2 log y is equal to log 2 plus log x. So this can be our equation 2. Let me just write that properly. So we have 1 and we have 2. Okay, so I think equation 1 is a little bit simplified, and 2, of course, we need to apply some logarithmic rules for us to properly simplify it. So we'll start with 1. So for 1, we have 2y is equal to 4x, right? So what we need to do, we need to have a standard equation for x and y so that it's easy for us to replace values and to solve the simultaneous equation. So we know that this can be rewritten as 2y is equal to 2 power 2x, right? So since the bases here are the same, we know that this is the same as y is equal to 2x, like this. So this we can name it as our equation 3. We can name that as our equation 3. And then next we have, let me use a different color so that we differentiate them properly. So next we have 2 log y is equal to log 2 plus log x, like that. Okay, so we know that this we can also write as 2 log y is equal to log 2x. We know that from one of the rules that we had earlier on stated, whenever we have 2 logs adding, so these bases are the same, we know that these numbers can multiply, so we can have log 2x like that. Okay, and then also this is the same as log y squared is equal to log 2x, like this. So the 2 can come on top there according to the logarithmic rules that we had stated earlier on. So since we have it simplified like that, the logs can cancel out. So we have y squared is equal to 2x. So we can name this as our equation 4. So since that is our equation 4, we can then solve equation 3 and equation 4 simultaneously, since the equation has now been simplified. So equation 3 is y is equal to 2x. So let's just write it on a new page. So we have y is equal to 2x. And that's our equation 3. And then our equation 4 Equation 4 is y squared is equal to 2x. That's y squared. Y squared is equal to, yeah, y squared is equal to 2x. Okay. Y squared is equal to 2x. So those are the two equations that we have. So this is our equation. This is our equation 4. That's our equation 4. So in order for us to solve this, since we have the value for y is equal to 2x, we can substitute in equation 4, which then becomes, we'll have 2x in here. We'll have 2x squared is equal to 2x. And then this, we know this is 4x squared is equal to 2x. Then this we can write as 4x squared minus 2x is equal to 0. Then when we factorize, we know that what's common there is 2x, so we can factorize that so that we have 2x minus 1 equal to 0. So we'll have two answers. We'll have 2x is equal to 0 and 2x minus 1 is equal to 0. So this, when you divide 0 throughout, it will simply give us x is equal to 0. And for this one, it will give us x is equal to 1 over 2. Will give us x is equal to 1 over 2, like that. Okay, so in order for us to find the values for y, we will say, we'll first of all find the value for y when x is equal to 0 and also when x is equal to half. So we'll start with when x is equal to 0. We can substitute in equation 3. So we have y is equal to 2. So this will be 0. Then y will be equal to 0. So we can say, therefore, when x is equal to 0, y is equal to 0. And then when our x is equal to half, we can substitute in any of the equations. I think equation 3 is simpler. So we can say y is equal to 2, then x, there is half, and then we say y is equal to 1. So we can also put a summary there. Therefore, when x is equal to half, y is equal to 1. So those are our answers for the simultaneous equation for equation 1. We move on to our second simultaneous equation, this one here. So we'll write it there. We'll write it on a new page. So the simultaneous equation is, we have log x minus 2 plus log 2 is equal to 2 log y. So that's our first equation. And then our second equation, okay, our second equation is that's log x minus 3y plus 3 is equal to 0. So we first of all start by simplifying our equations so that we have something, so that we have a simpler form which will be easy for us to solve. So we can start with our equation 1. So our equation 1 is log x minus 2 plus plus log 2 is equal to 2 log y. So we know from the previous rules that we had earlier on stated, when two numbers are adding and then the logarithmic bases are the same, these can multiply. So this is the same as log 2 can multiply by what's inside in here. So that gives us 2x minus 4, like that. And then when we look at the right hand side of our logarithmic equation, we can equate these to log y squared. The 2 simply comes on top. So since we have that, the logarithms can cancel, so that we have 2x minus 4 is equal to y squared, like that. Then this, what we have here, we can then name as our equation 3. And then for our other equation, so let me just do this. For this other equation, equation 2, where we have log x minus 3y plus 3 is equal to 0. So what we need to understand is that whenever we do not have any base mentioned here, we take it that it is base 10. We take it that there's a 10 here. So when we write this in exponential form, this is going to be x minus 3y plus 3 is equal to 10 raised to the power 0. So this then becomes x minus 3y plus 3 is equal to 1, right? I think we can utilize the space that's here. So, okay, let me use a different color so that it's just differentiated. So, we have this, right? Let me just rewrite it here. X minus 3y plus 3 is equal to 1. We can then say x minus 3y. We can then say x minus 3y plus 3 minus 1 is equal to 0. So this is x minus 3y plus 2 is equal to 0, like that. We have something like that. And then we can make x the subject. I think it will be easier to make x the subject here. So we say x is equal to 3y minus 2. So this then becomes our equation 4. So we can now solve our equation 3 simplified from equation 1 and our equation 4, which we have simplified from our equation 2. So we can write this on a fresh page. Where we have 2x minus 4 is equal to y squared. So remember, this was our equation 3. And then we also have x is equal to 3y minus 2, which was our equation 4. And so, since we already have x as our subject of the formula, we can substitute equation 4 into equation 3. So substituting will then give us 2, and then we have 3y minus 2, and then we have minus 4 equal to y squared, like that. And then when we multiply that, it will give us 6y minus 4 is equal to y squared. So this will give us 6y minus 8 is equal to y squared, and then we can rewrite this as y squared minus 6y plus 8. So we then have a quadratic equation. So when we have a quadratic equation, we simply just find two numbers that we can substitute, whose product will give us 8 and whose addition will give us -6. So those numbers are 2 and 4. So we can have y squared minus 4y minus 2y. Sorry for that. Minus 2y plus 8 equal to 0. Then we simplify this. We factorize. Y is common there, so we can have y minus 4, and then we have -2 there, then y minus 4, like that. Let's use a different color. So from the values that we have gotten, we can then write that as y minus 2. Oh, sorry, here we forgot to put equal to 0. Sorry, we can then write that as y minus 2 and also y minus 4 equal to 0. So the values will then be y minus 2 equal to 0 and y minus 4 equal to 0. This will give us y is equal to 2 and y is equal to 4. So we have found the y values. We need to find the x values. So we say when y is equal to 2. When y is equal to 2, you can pick any equation of your choice. I think equation 4 is simpler. So we'll have x is equal to 3. We put a 2 there, minus 2. So x is equal to, this is 6 minus 2. So x is equal to 4, like that. And then when y is equal to 4, when y is equal to 4, so we can still use this same equation 4. We'll have x is equal to 3, then 4 minus 2. So x is equal to 12 minus 2. X is equal to 10. So these will be the values of our simultaneous equations. Thank you very much for watching. See you in the other lectures.